Here we have a SAT math problem. Okay, let's go to the question. If x is equal to 2n root of 3 times x to the nth power positive 40, where n is a positive integer constant, what is the value of x to the nth power? Okay, in this equation, we have to solve for x to the nth power. Okay, now let me take this given equation as it is. It is x equals to 2nth root of 3 times x to the nth power positive 40. Okay, in my first step, what I'm going to do is I'm going to write this radical as an exponent. Okay, then let's write the stuff inside the radical. That is 3 times x to the nth power positive 40. Whenever I write a radical as an exponent, it has to be a fraction with numerator 1. And the denominator of the exponent over here has to be the index of the radical. The index of the radical is 2n, so that should be the denominator over here. So when I write this radical with the index 2n as an exponent, it will be 1 over 2n. Okay, now to get rid of this exponent 1 over 2n over here, let me raise both sides of this equation to the power of 2n. That is x to the power of 2n. And the right side also I have to raise it to the power of 2n. Then I'm getting 3 times x to the nth power positive 40 whole to the power of 1 over 2n. It has to be raised to the power of 2n. Then we get x to the power of 2n. Okay, here the base is 3 times x to the nth power positive 40 and the exponent is 1 over 2n. And for this complete stuff, we have exponent 2n. Whenever we have two exponents like this, what we can do is we can multiply the two exponents using the power of a power rule in exponent. Then we get 3 times x to the nth power positive 40 whole to the power of 1 over 2n times 2n. Okay, here this 2n will cancel. Then I'm getting x to the power of 2n equals to 3 times x to the power of n positive 40 whole to the power of 1. Whenever there is an exponent 1, we don't have to mention, we can ignore it. Okay, now this is the equation we have. Further, we can write this x to the power of 2n as x to the power of n whole to the power of 2. Because whenever two values are multiplied at the exponent, what we can do is we can take one of these two values as the exponent for this base. The other value can be taken as the exponent for the whole stuff. Okay, in these two values 2 and n, I am taking this n as an exponent for this base, and I'm taking the other value 2 as an exponent for the whole stuff x to the nth power. On the right side, we can write the stuff as it is. It is 3 times x to the nth power positive 40. Okay, here we find x to the nth power and here we find x to the nth power. To make the solving process easier, I'm going to substitute a new variable for this x to the nth power. So that is let y equals to x to the nth power. Now I can plug in this y for this x to the nth power in this equation. And for this x to the nth power, we have to plug in y. Then we get y and y square. I'm taking this exponent as it is equals to 3 times. So for this x to the nth power also, we can plug in this new variable y. So 3y positive 40. Okay, let me subtract 3y from both sides and also 40 from both sides to get this quadratic equation in standard form. Let me do it. So when I do so, positive 3y, negative 3 will cancel out, and positive 40, negative 40 will cancel out. On the left side, I'm getting y square, negative 3y, negative 40 equals to 0. Okay, here I got a quadratic equation in the new variable y in standard form. Once I solve for the new variable y, it can be replaced by the original stuff x to the nth power. Okay, I think we can solve this quadratic equation by factoring. For that, we have to multiply the constant of negative 40 over here by the coefficient of y square, that is 1. When I multiply this 1 and negative 40, I am still getting negative 40. Now I have to get two factors over here so that the product of these two factors is equals to negative 40 and the sum of these two factors is equal to the coefficient of y, that is negative 3. I think negative 8 and positive 5 will work. When I multiply negative 8 and positive 5, I'm getting negative 40. When I combine these two factors, I'm getting negative 3, which is a coefficient of y. Further, I have to divide both these factors by the coefficient of y square, that is 1. Okay, let me do it. Even when I divide them by 1, I'm still getting negative 8 and positive 5. Okay, now to get the two values of y in this quadratic equation, I have to change the sign of these two factors over here. That is, to get the first value of y, I have to change the sign of the first factor. When I change this negative sign, it will be positive. That is, the first value of y is positive 8. Now to get the second value of y, I have to change the sign of the second factor. Then I'm getting y equals to negative 5. Actually, y is a variable taken by us to make the solving process easier. Now we have to replace the y over here and here by the original stuff x to the nth power. Then I'm getting x to the nth power equals to 8 and here I'm getting x to the nth power equals to negative 5. According to the question, I have to get the value of x to the nth power. Here I got two values for x to the nth power. One is 8 and other one is negative 5. Actually, the given equation is a radical equation. Whenever we solve radical equation, always we have to verify the solutions we get. So here we got two solutions for x to the nth power, 8 and -5. Both the solutions have to be verified. Okay, for that, we need this term x to the nth power in the given equation. In the given equation, on the right side, we find x to the nth power. But on the left side, we just have x. So now to verify these two solutions, we have to get x to the nth power over here on the left side. So for that, we have to raise both sides of this equation to the power of n. When I raise both sides of this equation to the power of n, I'll be getting x to the nth power on the left side. On the right side, the n in the index of the radical will cancel out. We just get square root on the right side over here. Okay, now let me raise both sides of this equation to the nth power. Then the equation will become x to the nth power equals to square root of 3 times x to the nth power positive 40. So that is the n in the index of the radical is cancelled out. We just get 2 as the index of the radical. That is nothing but square root. Okay, now in this equation, we have to plug in this 8 for x to the nth power and also this -5 x to the nth power. And we have to check whether both these values satisfy this equation. Okay, first let me verify the first solution, that is x to the nth power equals to 8. Let me plug in this 8 for x to the nth power over here. Then I'm getting 8 equals to square root of 3 times 8 positive 40. Then we get 8 equals to square root of 3 times 8 is 24 positive 40. Then we get 8 equals to square root of 64. Then we get 8 equals to square root of 64 is 8. Okay, so the first solution, that is the value 8 we have for x to the nth power satisfies this equation. We can consider this one as a valid solution. Okay, now let me verify the second solution, that is the value -5 for x to the nth power. Okay, I'm going to plug in this -5 for x to the nth power over here in this equation. Then I'm getting -5 on the left side, because here we have x to the nth power. When I plug in -5 for x to the nth power, I'm just getting -5 on the left side. On the right side, 3 times for this x to the nth power, we have to plug in -5. Let me do it. Positive 40. Then we get -5 equals to square root of 3 times -5 is -15 positive 40. Then we get -5 equals to square root of -15 positive 40 is equal to positive 25. Then I'm getting -5 equals to square root of 25 is just 5. Okay, when I plug in the second value of x to the nth power into the equation, I'm getting -5 equals to positive 5. Actually, it's a false statement. So the second value of x to the nth power, that is this -5 for x to the nth power, does not satisfy the given equation. So we cannot consider this one as a valid solution. Therefore, the valid solution is 8. That is, the value of x to the nth power is 8.